Hello everyone, it's Peter here, Piotr Fisner. How you doing, guys? Hello. So, we get an update with my worst in the world solar panel. Now please look that this is the first 18650 which was charged by that panel. Okay, and here we got a volts DC. Okay, and let's check positive on positive, negative on negative, and it charged to 4.2, which of course it's over showing, so then it's dropping and it's dropped to 4.066. Now it's quite stable over there, yes, so I could still charge it to 4.2, but it's fine. I don't have a diode over there to prevent the pullback of the current. And then I've used these ones. These went from 0.6 or 0.8 volt. These are from old laptop battery, which I won't be using, so I've decided to open it and use these cells anyway. And these have at the moment 3.6. Okay, so it charged about 3 volts in them. About amperes, I can't tell you because I didn't discharge and charge, so I don't know wattage, I don't know anything. I just wanted, I've got 6 of them now, and the second batch is charging up. Actually, you know what, I'll put on the post and I'll tell you the second batch of these as well, what it is. Okay, so that one outside, which is charging at the moment, it's 3.56, so it's still about 1.2 volt. No, it's 0.1 volt about, and I will be able to put the last one, this one. So again, that's a bigger side, so that's the minus. And let's see, because that's the empty one, so you'll see that's what it was. It's 0.6 volt of a volt. So these are in a parallel, so the top positive and the bottom negative are together. Now I've got my spot welder, so if I will charge all of them, I will be able to use them to make a proper battery pack. Now I can't use too many of them, can't connect too many of them, because then that panel won't be able to charge it, yes? So I need to decide how many I will do. Probably I'll leave them 2 each and see how much I will be able to discharge and then charge, and then I will be able to maybe add up, like maybe try to, because I know that 2 of them are charging okay. So the next time I would be able to maybe connect these two in the parallel again, and see if I will be able to charge that one, and if that will be still okay, because that's only 25 watts maximum power. So you know, so I know it will be going slow, yes, it will be going slow, but it's actually going quite well, because it's 20 watts and that's one cell. It's 9 to 13 watts, yes, because I don't know the capacitance, it's nowhere written on it. I would have to go and check the packaging which I've thrown away, so then I would be able to divide by 6 and I would know. But doesn't matter, actually doesn't matter. What I want to say is let's try to charge them overnightly. I mean, let's try to charge them today, then overnightly I will leave them, just leave them, and I will write down how many volts was, you know, when I was going to sleep, and then I'll mark on them as well, marks like 1, 2 and 3, and then this one it's on its own, so I'll mark it, and in the morning I will be able to check which one was good and which one is maybe dropping voltage too much. So then I will be able to cut it in half and then see which one has less and which one has more. And if some of them has, well, I haven't seen internal resistance because I've switched to ohms and I had nothing, yes, so the internal resistance should be good of these batteries. So only what we care is how much charge they can hold right now. And I've got a good news, I'll show you the pictures. One of the customers said that he can give me this Sharp, which has a maximum, where is the voltage at the point of maximum, it's 23.7 and amperes it's 7.60. This panel he can give me, and he can give me this one, another one, which has 36 voltage at P max and current at P max it's 5. So 180 and 190 watts panels I can get from a customer, so that's 370 watts. So I need a battery now and I need an inverter. So one of the customers gave me some similar inverter which what we will gonna build. Okay, so these are 500 watts times 4, and that's total of 2000 because that's showing 2000, and that's pure sine, so that means 50 hertz, yes, 230 VAC volt AC, and that should be, you know, that should be okay. But this inverter has a poor power, there is some issue with it. But because it's a build, the way I will be building, I will be able to compare it with the one which I'm gonna build. Yes, and plus I could use some components. Plus I've got coils here. Yes, so I've stopped ordering from China. I'm waiting when the stuff will come from China, and especially the PCBs. And when the PCBs will come, I will be able to use some of those components, you know, and build my own inverter. And then see how those components are working. If they are working fine, I will be able to verify, much easier diagnose this inverter, because that's the closest to what we've got. Yes, so the design which I'm planning to build, I mean. So yeah, you've got an input 12 volts, and unfortunately 12 volt might not be good for me. And why it's so? Because if those, yeah, that board is the controller. Okay, and we've got it here. I'll show you one of those two. It's really similar. If you would closely look, maybe I will just open it for you so you can compare it yourself. Oh, there's only 1 pin difference in between them. Plus here are some LEDs, at least one here, and I think second was somewhere there, or maybe I'm wrong and it's only one. And plus here is a crystal, EGS002. This one is B, so 002B, but it doesn't matter, yeah, but it's similar. So this one doesn't have it written. They've got similar components, they are not perfect, but they are quite close. I don't know if pin to pin, because here is one pin missing here at this place, and I've got that pin here on my board. Again, I don't see here a how you call it, I don't see here a quartz, yes, so there's no quartz here, but those components are similar or the same. I'm not sure about this chip, because it should be EG008 or something on my one. Then those I need to check MOSFETs, SGH 60 and 60, yes, those, compare them with those which I have. Then in our design, the open source one is as well resistor and the diode, and as well those 104 or whatever these capacitors are. So it's really similar design, yes. Okay, so now it's my video clip about the solar panel. But can I go out? Can I play it? Is it possible to play it here? Okay, that's rude. I was trying to show use. Okay, maybe, yeah, okay, now it's taking, it's loading, will take some ages, but hey ho, at least trying. Come on, load it. No, nothing. Oh guys, if we will be doing like that, it's a waste of time only. Okay, it doesn't wanna. So what I wanna say is it should literally, it's nothing too complicated. Okay, I'll pause it, I'll prepare it, and I'll show you. Okay guys, so yeah, I've got a video, and the video is showing that, you see, I'm touching this and it's charging up to 4.08, and keep in mind it's the worst soldering possible. Yes, you can't solder worse than that. and it's okay. Now I will disconnect the battery, the 18650. I will disconnect and I will show you how much this panel giving us voltage. So give me a wee second. And here is 5.9 without the battery. Okay, so yeah, you can see that this panel is not the greatest. Plus I made wrong connections, so every second row, I'll show you here. Okay, so yeah, you've got a one row here, and then here this row should be, this one should be opposite 180 degrees here, and then I wouldn't have to have those long cables to the other side. I would just come here with a wire, go like that, connect at the top, this with this, and then connect this one here, again here, to the next one, and so on to the very end. But unfortunately, because I've done such bad design, I call it the worst photovoltaic solar panel, and you see it is what it is. So at the end of the day, we've got components which I bought at China. They came. I've got some other inverter with a similar design to what we have in the open source design, what we looking forward to build. 3, I've got some enclosure as well to use, connectors, etc. Yes, so that the first one which I'm going to build, probably I'll build 2, because there is one customer which want to give me those solar panels, so I will build one and this customer will have it, and I will have the second one, and I will be trying to use it. Now if I'll get those solar panels from him, I think I need to rethink if I want to have 12 volts input. I think I will either gonna lose and convert it to 12 volts, and then we'll charge some batteries, 12 volts batteries, or I need to create the 12 volt inverter for this customer and check if I'm capable of redesigning the inverter and build one for myself which will be 24 volts, because those 2 solar panels will at least produce those 24 volts. So I'm thinking, you know, what's the best approach, because if I've got solar panel which produces 24 volts, I'd rather use battery pack of 24 volts and inverter 24 to 230 volts than have one step extra by converting 24 volts to 12 volts, then have batteries of 12 volts and then inverter from 12 volts to 230 volts. But as well depends on the price, because if I will see huge difference in the price, then of course I don't want to have dear, yes, I will choose cheaper. So I will be looking into those 2 solutions, because there will be probably more people who are as well thinking the same way. Okay, I've got 24 volts, what should I do? Yes, so yes, this open source design need to be rethinked, that it will be 24 12 volts, yes, and those 2 need to be available for people, and I need to test both of them as well. Okay, so we will probably end up with 2 inverters, not 1. But it is what it is. If I'm going to have these panels next week from the customer, I'm gonna test them. I'm gonna see, you know, if and how much they are for real producing, because as far as I know these are used but still good solar panels. And the only downside is it's not 12, it's those 24 volts. So yes, I could use 2 batteries, like a deep cycle acid lead acid batteries, 12 volts, or compare 2 of the lead acid batteries 12 volts with a price of 1 battery but 24 volt. You can as well get them, they are dearer, yes, But if I would go for 2 times 100, well, I'm considering at the moment at least 60 amp hours. Yes, that's the minimum. But I would go for 100 amp hours. That's not perfect for the home, but it's 12 volts times 100 amp hours. We're talking 1200 watts. So then if I'm gonna use deep cycle, let's say, and I will use maximum of 50%, we're talking over 500 watts used from each battery, which is actually a lot, because whole lighting at home, I would say that maybe, if lucky, whole lighting at home every day would be supplied by that. Yes, even if I'm wrong, let's say, even if I'm wrong, it won't be too far, because we've got 1, 2, 3 rooms, let's say 3 rooms, lighting for about 11 watts for maybe, let's say, 10 hours. If so, that's a maximum. So 10 hours, 10 watts, that's 100 watts per room, and 3 rooms is 300 watts, and the rest is a toilet, but you don't sit all the time in the toilet. Yeah, let's say you will use 20 watts for the toilet for the whole day, maybe, but that's, I would say that's the maximum. You're gonna use about, let's say, 30 watts for the kitchen, which again is, in my humble opinion, exaggeration, because we've got extra spotlights. So I would say for the main light, let's say another 30, so that's 50 watts. So we're talking like 350 watts for the lighting at home, and then just like a corridor, etc., and over usage in some of the places. So 500 watts is for the whole lighting at home for a whole day. So that, you know, what I can produce from the one battery, use it safely as a safe cycle, one calculated as a one cycle. If I can go for deep cycle, so discharge for 50% of the power of the battery, then we're talking one battery will last me for all the lighting at home. So I can switch off my fuse, plug in into the socket, I mean the inverter, yes, and then use it. That would be, that's it. Or better, think of a way to not use 230 bulbs, but use similar lumens based on your voltage without the inverter. And then if you can transform the whole house this way, then you don't need an inverter, using your battery storage 1-to-1, and using DC current, so no inversion or whatever, no losses, yes? But the question is, am I capable of doing that, and is it worth? That's the question later. Once we will have the power, I will be asking myself, and I will be talking about designing it if that will be the case, because I need to check which LEDs have which lumens, so probably I need those bulbs because they've got proper power. Then I need to use watts, which is volts and amperes, what they are taking, and can I use 24 volts? Yes, because if I would have 24 volts in those batteries, then I can of course take it straight away. Or 12-volt battery, 12 volts, yes, so I need to check what I can do over there. If I can do it in series, yeah, I can do it in series. It's not a problem. They are like 6 or 8 in series anyway, so you know, it's not a problem. They will be only 2. If I can have less lumen and they can last for longer, and I don't need such light, yes, I would go for it, and then the battery usage would be even less. So we will talk about those. We will do additional projects once we will have the main source of my extra voltage at home done. Then we can go for that. What else I wanted to tell you? Yes, okay, so I won't be destroying that worst panel ever, but I'm thinking about making it more robust. That's mean, you know, making it that you won't touch it and you will damage it. Yes, you will touch it and you will damage it. So I was thinking redesign, but for now I will leave it as is, because that's for testing, not for anything else. Next week, when I will have solar panels, I will have to think what is my approach. Do I want to maybe that's a tricky one, guys, because 24-volt panel, it's mean I need to take 24 volts and store it somewhere. And if I will get 24 volts stored somewhere, I need to use those 24 volts, or if that would be two 12 volts batteries, I could use of the energy from one battery, but then it will be depleted. Yes, so I would have to make sure that when this is discharging, the second battery is charging it, and the solar panels. So I would need a load balancer for it in that case. So the question is it worth to do load balancer, or maybe just buy the 24 volts battery? But then again, if I want to invert it and I've got inverter 12 volts, I'll need to think, step down to 12 volts, but that will be a lot of amps. We're talking about 5 to 10 amps. So if I'm gonna use DC to DC back converter from 24 to, let's say, 12 volts, then I need to have a nice radiator for the MOSFET in the back converter, because it will consume, you know, like a lot. Yeah, you see, that's the question for next episode for the for this thingy. Yes, guys, that's it in this episode. That's all I wanted to show you. Let's see if only the voltage have dropped significantly or not. That's a plus, that's a minus. No, still 4 points. There is a hope in this cell, because overnight it did hold, and now it's 4.06. good. 4.06 it was, yeah, 4.06. and now these ones 0.6, so that's the discharged one. 3.63, so it's still dropping, because it was 3.65 about. So I need to see if this will keep on dropping, because if this will start to drop more and more, one of those two cells would need to be out. That means it's faulty. If this will stabilize, yes, because I don't want to charge it more today, I want to charge the other ones to as well 3.6 something. It should be about that, but I wanted to charge a bit more. I still got about less than 2 hours of sun, so maybe in the next half an hour I will go disconnect it, and I will put the last one, which has 0.6, yes, this one, and that will be the last batch of batteries for the charging for today. Hope you've learned something. If you've got questions, leave them down below. You can get old laptop batteries from old laptops. Yes, sometimes people are throwing their laptops and they contain those 18650s, so you can get them for free. Probably you won't be lucky to get solar panels for free, but if you can buy cheap panel, you can charge your own ones. Yes, of course it won't be free, you'll have to pay for it, because if you're going to build one, you see me struggling, so you know it's not nice. Plus, if you've got those, you can solder them. I'm sometimes, when I had no spot welder, which is not dear, you can watch one of the videos have this spot welder, I've DIY it. So if you can't buy this DIY, which is the cheapest option, which is not really dear, then you can solder it. If you can solder them together, they will still work. Just use quite thick cable, you know, it depends how many. You want only 2, then don't bother with too thick wire. But if you want to connect 4 of them or something, use quite thick wire now. Yes, thank you for watching. I hope somebody have learned something from it, and we will see tomorrow if I will be able to get this holding any capacitance, because that's for free for me. You know, like I've spent 108 pounds, 120 pounds, let's say, about 120 pounds, maybe a bit slightly less, and there is 10 cells used out of 100 cells, so that's 1/10, so that's about 12 pounds. I've spent 12 pounds, guys, for that solar panel, and I've got net positive on the energy now. Okay, so yes, it will take me whole year if I would produce every day properly out of that panel, and I will spend more probably on the silicone or something to cover as well, so that I will touch it and it won't break. Plus my neighbor want to give me some glass from a window company, and you know, and no additional cost. So if we're talking that I can during the day charge, let's say 6 of them, so we're talking about 100 watts of energy for real, guys. So every day you've got 100 watts. If you live in alone, let's say, and you've got like a 6 to 10 watts bulb, guys, we're talking light for the whole night. So you're charging your solar panel, and then at night you've got a whole, from that small panel you can have light for the whole night. Yes, so if you would have twice big panel, you could still run something like a smaller laptop, or laptop which uses less energy, or small TV. Yes, you could still, it would be still possible, yes, instead of a light, let's say. Or if we're talking like 4 times of that, like 100 watts, guys, now we're talking that you can and watch the TV or a laptop and use the light and do something else. But each time you need to keep in mind storage. So find a way how to get these as cheap as possible. Like me, you know, I do have about up to 50 laptops, like really old ones, and yes, some of these battery cells will be dead. That's why I'm loading them halfway through, leaving them overnightly, see how they are holding the charge, and then I'm charging to the very end if they are quite good. Yes, if they are dodgy, then I'm you know, taking them away. Yes, not throwing them, but I'm taking them away. So I'm not continuing charging those which are useless to me. But I know as a fact I can have this 100 watts per day. Is over 100 watts per day of the energy. So that's, for me in person, it's a good start. With that dodgy solar panel, the worst in the world, spot on, guys. I wish you to do something as well and produce a bit for yourself. Why pay so much for the electricity if you can save up? Yes, thank you guys for watching, and see you in the next video. Bye bye.